No other part of the vehicle requires as many control strategies as the regenerative braking system. It is a key aspect in order to make the electric vehicle economically competitive with conventional cars. The control system decides when the regenerative braking force is sufficient for the desired braking process and when the additional support of the frictional brake is required. Good day and welcome to the 12th episode of Let's Talk About Electric Vehicles. My name is Teresa, I'm an environmental economist, and in my free time I host this podcast about electric cars because I have a never-ending passion for innovation and technology, and I love to learn about how to improve our transportation system. By listening to this podcast, you will learn about what academia says about the performance and the potential of electrified transport systems, as I usually refer to academic research papers as my main source of information. Sometimes I conduct interviews with experts, and sometimes I intentionally leave questions open or just ramble and speculate and ask you guys for your opinion. If you want to join the discussion about electric vehicles, feel free to check out the forum on electricvehiclepodcast.com or write me an email to electricvehiclepodcast@outlook.com. I'm always excited to hear what you think. Anyways, today we will talk about regenerative braking. When people talk about regenerative braking, they usually refer to the ability to gain energy back from the vehicle's deceleration. In electric vehicles, this energy can be used to recharge the battery. Regenerative braking is considered as one of the key factors for the economic performance of electric vehicles. It might even be the pivotal component for electric vehicles to outperform diesel or gasoline cars. Regenerative braking is quite controversial as it comes with some issues. The more you seek to maximize the potential recoverable energy, the more complex the braking system gets. And higher complexity does not only drive up the cost of the braking system, but it has also a detrimental impact on the vehicle's stability and safety. For example, regenerative braking systems can be in conflict with the anti-lock braking system, the ABS. And not forget to mention the additional burden on the battery of frequent charging and discharging. Recall that batteries don't like frequent charging and discharging. Besides the technical issues, some Western countries additionally have very strict regulations when it comes to vehicle braking systems, which makes the implementation of regenerative braking systems even more challenging. In today's episode, we unravel the benefits and the challenges of regenerative braking. When a vehicle decelerates, there are various forces that cause it to reduce its speed. There is, for example, the rolling or air resistance, or a potential uphill drag. As for the braking force, we distinguish between the mechanical frictional braking force and the regenerative braking force produced by the motor torque. The latter is the one that can be used to regenerate energy. If you want to maximize the recoverable energy, the first step is to change the distribution among all of these deceleration forces and make the regenerative braking force the most pronounced. For example, the lower the rolling or air resistance, the higher the regenerative braking force. Unfortunately, the regenerative braking force is naturally limited by the motor, by the energy storage system, and some other factors. The higher the motor's torque or power, the more energy it can recover. How does the energy storage system limit the maximum recoverable energy? Well, first of all, if the storage unit is fully charged, it cannot capture any more energy. And secondly, batteries can be very sensitive to load mismatch or overcharging. In order to not damage the battery, the charging power and the current should not be too big. And in order to recover as much energy as possible, the energy storage system should have both a high specific energy and a high specific power at the same time, and that is obviously very challenging. A possible solution for that problem would be to use a combination of a battery and a supercapacitor, so to combine the advantages of both systems and to compensate their weaknesses. If you want to learn more about batteries and supercapacitors, check out Season 1 of Let's Talk About Electric Vehicles, where I explain all sorts of different types of energy storage media. And now there are several ways of how to structure the regenerative braking system. In order to maximize the recovered energy, everything has to coincide: the motor, the controllers, the battery, the cable size, and so on and so on. Manufacturers have to decide whether they want to install it only on one axle, which would be the front axle because it has more braking force, or on all axles. If they choose the one axle version, it is inevitable that a substantial part of the braking energy dissipates in form of heat at the rear axle. On the other hand, if they choose the all-axle option, it could drive up the cost and decrease the vehicle stability. What some of you may not know, the performance of regenerative braking is highly sensitive to fine-tuning. Factors like the current vehicle mass, the position of the mass center, so front versus back, and the current driving pattern, and the current rolling and air resistance, they should all be considered in the settings of the braking system. So therefore, the key aspect of the efficiency of regenerative braking system lies in the control strategy. One of the papers I refer to even says that no other part of the vehicle requires as many control strategies as the regenerative braking system. It has to satisfy many important criteria. Some of the goals are even conflicting, which makes life very hard for researchers and developers of electric vehicle technologies. So let's have a closer look at the duties of regenerative braking control systems. First of all, it determines the distribution of all braking forces and coordinates between the frictional braking system and the regenerative braking system. Think about what that means for a second. In order to maximize the recovered energy, the control system has to decrease the frictional braking force and increase the regenerative braking force. In other words, if the driver pushed down the braking pedal, the control system might decide that it is not yet necessary to activate the friction brake and go with just the motor brake a little longer. This is a very sensitive area. The control system has to make sure that the driver is not irritated and does not lose his trust in the braking system. Therefore, the control system has to account for the perfect pedal feel compensation as well. The control system decides when the regenerative braking force is sufficient for the desired braking process and when the additional support of the frictional brake is required. Aside from the goal of maximizing the recovered energy, the control system additionally has to optimally distribute the braking force between all four wheels in order to maximize the braking performance and therefore maximize driving comfort, vehicle stability, and safety. As for the relationship between the regenerative braking system and the anti-lock braking system ABS, which is activated in sharp deceleration events, there is two possibilities how to handle it. In the first scenario, the braking torque drops to zero when the ABS event occurs. In this case, no energy can be recovered. The second possibility is an integrated RBS-ABS transmit unit, RBS, regenerative braking system, ABS, anti-lock braking system, transmit unit, which enables to capture energy even during the ABS event. It is technically possible, but it requires both systems to work together, and therefore it increases again the complexity of the whole braking system. The two goals, maximum recovered energy and maximum braking performance, stand in conflict with each other. To maximize the energy gain, the control system should distribute as much braking force as possible to the axle where the regenerative braking system is installed. So we learned that manufacturers have to make a certain trade-off decision between stability and energy efficiency. This is where government regulations about braking systems play a very important role too. The ideal control system is as simple as possible. It preferably uses standard vehicle components to decrease the complexity and the cost, and it should increase the braking performance to make the braking process as comfortable and as safe as possible, while it should also maximize the recoverable energy, whereas the last two stand in conflict with each other. Whew, not easy. This is definitely not easy for manufacturers. So now I was curious about the actual performance of regenerative braking systems. Since it seems so complex and expensive and even detrimental for the vehicle's safety, I wanted to know how much energy regenerative braking can really recover and whether this is all worth it. Therefore, I refer today to a study by Wagner and others who conducted a performance test on a Mitsubishi car. They find that the reduced energy consumption through the regenerative braking system increases the driving range of the vehicle by 11 to 22%. So why is it such a wide range, 11 to 22%? Because they further find that the performance highly depends on the system settings and on the driving pattern. That emphasizes again how important it is to adjust the RBS settings to the vehicle load and tire conditions. Another interesting outcome of the study, they find that an electric vehicle with regenerative braking uses the friction brakes more efficiently, and therefore the electric vehicle has a lower brake pad wear, which not only reduces the maintenance cost, but it also has a positive impact on the urban air quality since the brake pad dust is therefore reduced too. In particular, they find that regenerative braking reduces the time of friction brake usage by around 50%. Speaking of numbers, I have one interesting number for you. 16 kilometers per hour or 10 miles per hour is the minimum threshold for the test car of the experiment to be able to use regenerative braking at all. If it drives faster than 16 kilometers per hour and then it decelerates, the regenerative braking mechanism is activated and otherwise it is not. Now that we know more about the benefits and the drawbacks of regenerative braking systems, you can make your own conclusion about it. Let me briefly summarize the content of this episode. Regenerative braking means that the counter torque of the motor in deceleration processes can be used to generate energy and recharge the battery. The electric motor therefore works as both a motor and a generator. It is a key aspect in order to make the electric vehicle economically competitive with conventional cars. A practical experiment showed an increase in driving range of up to 22% and a reduction of brake pad wear by 50%. Unfortunately, regenerative braking makes the braking system more complex, and in order to maximize the recoverable energy, you have to shift as much of the braking force towards the motor torque and away from the friction brakes, and therefore you might have to cut down in braking performance, braking comfort, and safety. If you want to share your thoughts about that topic, feel free to visit the forum on electricvehiclepodcast.com or send me an email. We have reached the end of this episode. I hope that I could teach you something new today. You'll find all of my references and contact information in the show notes. Please don't hesitate to reach out to me for feedback or topic suggestions. We continue talking about electric vehicles again next week, and actually I have prepared a very spicy episode about a genius invention that could, if it is true what the inventor himself says, make the charging of electric vehicles redundant. What? Yeah, you heard me right. Okay, let's find out more about it next week. Have a wonderful day, wonderful remainder of the week, and bye!